Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at expanding brackets. So this is where you start with a set of brackets and you end up with an expression that has no brackets. So to expand each of these, we use the distributive law, so called because we take what's out of the brackets and distribute it to everything inside the brackets. Now remember, in algebra, if no operation is written here, it means times. So what we do here is we go 3 times x and then 3 times positive 2. So we've expanded the brackets. Our answer has no brackets. All right, let's look at this second one here. So here we have 3 terms in the brackets, but we still do it the same way. We distribute what's outside the brackets to everything inside the brackets. So 2a times 3b is just 6ab. 2a times negative 4c, 2 times negative 4 is negative 8, and then write the pronumerals, and 2a times negative 5. So for this last one here, we'll use the distributive law again. This time it's going to end up being a quadratic. We go 3x times 6 is 18x, and 3x times negative 5x. So 3 times negative 5 is negative 15, and x times x is x squared. So this here is called a quadratic because there is an x squared term, as opposed to these. There was no squared term. We're going to be doing a lot of work on quadratics. So now what we're going to do is look at expanding 2 sets of brackets. So when we're expanding 2 sets of brackets like this, it's called a binomial expansion. So how you do that, you can use the FOIL method. FOIL is just an acronym, each of these 4 letters representing something. It just helps us keep track of what we've multiplied by what. So when we're expanding brackets like this, the idea is you have to times everything in the first bracket by everything in the second bracket. You have to times x by each of these. You have to times 3 by each of these. So again, FOIL just lets you keep track of what you've multiplied by what. So for here, x times x is the thing that occurs first in each bracket. So you get x squared. O, what's outside, in the outside of each bracket, x times negative 3. The insides, what occurs inside each bracket, is now positive 3 times x. And then lasts, the thing that occurs last in each bracket. So this is 3 times negative 3, which is negative 9. So with binomial expansions, you'll usually have to simplify. So we have 2 like terms. Negative 3x and 3x are like terms. In fact, negative 3x plus 3x, they cancel out. That just equals 0, and you're just left with x squared minus 9. That's our final answer. We've expanded. We started off with some brackets, ended up with something that does not have brackets. All right, let's look at this one here. So first, the thing that occurs first in each bracket, 2x times 3x. Outsides is 2x times negative 1. Insides is negative 7 times 3x. And last, negative 7 times negative 1. So once again, we have 2 like terms here. So we simplify this. 6x squared doesn't have any like terms, so we leave it alone. Negative 21x minus 2x is negative 23x. And then the 7 has no like terms, we leave it alone. This is our final answer here. I can't simplify any further. There are no more like terms. So what about something like this, 3x plus 4 squared? Well, you know when we square something, we are multiplying it by itself. So what you can do is you can go 3x plus 4 times itself, and you can use FOIL again. But there is a quick way to do perfect squares. It's called a perfect square because of this squared. So the quick way to do it is you square the first term, so 3x squared. 3x times 3x is 9x squared. You square the second, so 4 squared is 16, 4 times 4. And there is always a middle term for perfect squares. People often forget this. You can't just square the first and square the second. You need to also put in a middle term. So what goes in the middle is 2 times 3x times 4. So 2 times 3x is 6x times 4 is 24x. So that's the quick way to do it. If you don't like the quick way, don't understand it, you can use FOIL as normal. So I'll show you the quick way again here. Because it's a perfect square, we can square the first, square the second. Now, negative 9 squared is positive 81. Squares are always 0 or positive. So what goes in the middle of these is 2 times x times minus 9, twice the product of the two terms in the brackets. So 2 times x is 2x, times negative 9 is negative 18x. So once again, if you're uncomfortable with that method, you can just do x minus 9 multiplied by itself and use FOIL as we did in the previous examples. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.